50 experts from all over the world are studying current curved.
Okay, hello guys. The class better run. Yeah, let's begin our today class. Okay, and the last class, I gave you external interesting homework yet, and yeah, I just let you to find a concrete structure building, to introduce it, and to talk about it. And in the Wenzhou campus students, you can do 10-minute presentation, right? And if students not here, yeah, it also doesn't matter. You can just write and collect some information and about one A4 page word can send to me. It's also okay. And and students in Wenzhou also can do this type of homework because sometimes students feel shy to in here to talk. It doesn't matter, but yeah, as a teacher, I encourage you that it's a chance, right, to share your opinion, your idea, yeah, and something that other people to know you. Yes, it's really cool, right? Yeah, and here I just give you a sample that what I focus, what I major, or in my doctor period, my research topic is about this type of structure, the submerged floating tunnel. And if you are interested about that, also you can find some lots of material that's in the web. And here I just introduce a little information about that. The submerged floating tunnel is really a new concept that is different with the immersed tunnel, yeah, and also different with the bridge, right? What the function of the submerged floating tunnel that can across, they provide a way for like offshore peoples. They cross the long waterway, but the tunnel, this type tunnel, float on the sea, right? Float on the sea, and they use the pontoons to float, and also different support type like tether to because for we know a board like inside they had iron and they had a value according to Archimedes principle buoyance because of its own buoyance they can balance the gravity so it can keep balance so float on the sea, yeah. And what the advantage of this type of structure that it can, yeah, because we know there's a wave of bad weather sometimes, right? For near the seaside, tsunamis or another load. But for submerged floating tunnel, yes, it's float on the sea, and the wave just on the surface, right? On the surface. So they have a little, almost do not affect the structure, yeah, do not affect structure. So, yeah, my research topic just about this type of structure, yeah, and yeah, I also published some papers, and yeah, it's a really cool thing, and although until now there's no real submerged floating tunnel established in the world, so yeah, in my dream, yeah, for my life, can see one day can see this type of structure can be realized. Yeah. So here, yeah, I just show you a good different the concrete structure. Yeah, okay. And if you are interested about that, after class, I will show the whole video to play it. Okay. Now, let's go back to the class. Yeah. What we Okay. Yeah. Yeah, because the holiday will come, but I have to let you know the COVID-19 still the situation is serious. So I hope students can to obey our school's management, and do the personal protection work and mask work, and yeah, and reducing to go out, reducing go out. And if you are free to holiday, you can read some book and learn something. And if you also can choose to watch TV or movies. Yeah, these things I want to see it. And then now let's review. Let's review what we learned last class. Yeah, last class what we talk about the action, right? Action, some type of different actions. And here's attention. We classify different actions according to whether it varies with time or not. We classify the action as, can you tell me which type of the action that we classify it? Yeah, vary with the time. Yeah. Okay, Zhiqiao, you can answer me? Can you answer me? We according the action, whether it varies with the time or not, we classify action, how we name it, how we define this. If it varies with the time, we name it action as which action. Yeah, now let's just review what we learned last class, right? Whether it will vary with the time or not. I use an example, the vehicle load, right? Vehicle load pass through the bridge. The vehicle load vary with the time and also vary with the space, right? Space vary with time. I drew a beam, there's a load. So how we name this type of load? Okay, who want to try? So I will call someone. Lowen here? Not here? Okay. So find the guy, not here. So Huang Jingya, can you answer me the question? Yeah, my question is, if the action vary with the time, yeah, how we named this action? Yeah, variation action, right? Yeah, okay, thank you. Yeah, and also different, they do not vary with time, it's permanent, right? Permanent, yeah, and I use gravity, yeah, as example to explain the permanent load. Yeah, okay. So, and also we introduce another concept, right? Resistance. How we to describe a material resistance. Who want to try to just say something about how you to know or to explain if someone asks you what's the resistance of a material, a member or a structure. So how to answer that? What's resistance of a structure? Want to try? Oh, okay. Zheng Jia, yeah?
It can withstand actions without chemical failure, maybe like bending,
Yeah, bending.
bending resistance,
Yeah.
extension.
Yeah, extension. Yeah, okay, thank you. Wow. Yeah, that's enough. Because one thing just learn in the class may not enough, right? We need to after class we need to read and to enhance your memory to know this different the concept. The resistance for us, just Zheng Jia said, like bending resistance with the moment applied to the beam, they need to withstand this load. Yeah, but another thing is important. The material should not be filled. Right? It should be not filled, be good. If it filled, so that means the resistance is smaller than the load. It's brought. So that resistance, I will further to ask. So the resistance, which factors that are related to the resistance?
Material.
Yeah, you are the more you, right? Yeah, more you. Yeah, can you try? Yeah.
Material type.
Yeah, material. Yeah, materials.
Structure design.
Yeah, structure design.
Cross section of the beam.
Yeah. Geometric things like a section, cross section. Yeah. Okay, thank you, more use. Yeah, good. It's good. Yeah. What? Why? No, doesn't matter, right? Because you answered in class, I did give you scores, little scores, and it will count. Yeah, it will count in the final the comment, final remark, right? Yeah. I just encourage you, but it doesn't matter. Okay. You need to do some review, and listen carefully in the class, right? These things is a basic, it's just a basic for you to learn class. Okay, and we also talk about reliability, right? Reliability that we see if the structure has a good reliability, that means in the design working life of this structure, right? It can fulfill his basic requirement. Like if we design a building, generally the design working life is 50 years. And we hope in this period of time, the working do not destroy of the load and can keep fit, can provide its own function. So here is things we just you pay some time to review that. And today, I remember to here. the reliability. Today, and we continue to learn what's the design working life. That design working life. That means for structure, for structure or part of it, because structure they lots of members to consist the whole structure, like window, like wall, like column, like beam. These are the structure member, just a part of the structure, right? There's the whole building in the whole structure, and a part of it be used for its intended purpose, like hospital just provide for the doctor they working something, and also because we know some working place and the office is different, because people in these buildings they do different work. So like if workers in the factory, the buildings for factory, because there will have a heavy machine or another thing, so the load they will be different. So we see with the structure part of it, for its intended purpose will be different, right? But so here, we named it intended purpose. So without major repair. Major repair means that damaged really heavily. But we can accept the small repair, right? Because some wall they peel out something, and we just do this small repair should be allowed. So for here, the design working life, we need to know there's a without major repair. And here I captured some different from the code. They classify for different categories. There's a 5 levels. And for general, the building structure and other common structures, look at here in the 50 years, right? 50 years. But we need to know the temporary structures, like, because sometimes we will see in the field there is just some small building. There's no people living there. Here in these buildings, we just put some toys and maybe some animal like corn and some. So there's a farmer, right? Farmer, do not people living there. So for this type of structures, so his working life can be small, can be shorter, right? Can be shorter, and that means these things we know. If the design working life longer, right? Longer, that means we need to pay more resource and more material, more higher degrade materials to build that. But for the working life smaller, that means we can use different material like just wood, and do not use the metal in these buildings constructed. So like here, the agriculture is similar structure. So here, we just classify different five levels, and the different levels corresponding to different working life here. Do remember here we divide 5, and with the categories numbers increase, the working life should be longer, right? Here, that's a principle, and we just realize that from the code. I just captured this table from the code, and the code see that. So we need to know familiar about this principle. And the different here is a safety class. Safety class use the symbols CC. Okay, CC. What's different here is if the structure building has a CC3, that means this safety class is really really important, right? Really important. The high consequences for loss of human life. That means if these structures damaged or it's failed, so it will cause the economy catastrophe, some terrible things. So here is the numbers. CC3 is the high, CC2 is a medium. They carry some office buildings, public buildings. They had a corresponding true. All right. The working life, there's 5 levels, but for the safety class here, divide 3 levels. Yeah, and here, why I present this table and see something about that, because in the future, in the structure design, yeah, you will, according to the importance of the buildings, you will choose different coefficients. Later I will see, but here, just here, I just hope students should have this concept to realize that we do some classifications here, to roughly to divide and with different degrade with different grade structures, and we divide that. Okay. If you have any problems, just ask. It doesn't matter, because I know maybe tired after the before the class, right? Before class, so maybe tired, but it's okay. It's okay. Yeah, sometimes before I also have another class, so I also tired. So sometimes I can focus on something to talk and to see. Yeah. But we need to understand each other and do the good things, right? Yeah. Okay. Yeah. And before you have class, the last night you need to sleep early. Yeah, that's also will be good for the next day's class, right? Okay. Yeah, and know the important and there are different important structures. I introduced the 3 structure design method here. 3 design method. And the first one method is allowable stress design. Yeah, it's proposed in early stage. In this stage, people design just really roughly, and how to know just it's based on the principle that stress. We just we just ask the resistance to the larger than the load, right? We can use a formula to easily to describe this method, ASD, right? In this design method, the resistance, right, should be larger than the E. E is the action, right? Action I mentioned before. R is the resistance. Right? And with this method developed, people find here we just think there is a multiply 1, right? 1.0. And it will be dangerous because sometimes the action we calculate may be not accurate. we sometimes will they have the deviation, right? Deviation. So the actions we calculate maybe 10, but actually it maybe come to 20. For the resistance, if we calculate the 10, we design structure, the resistance is a 15. 15 is larger than 10. In the calculation, we think the structure is safe, right? But actually, the deviation is a 20. So it's actually the structure is danger, right? Because here, so we developed, we use a factor. We bring a coefficient in the formula. So the method developed to here, the load and the resistance factor design. Yeah, factor design. Will gamma, or some weird, it will gamma 0 or gamma R. But we can transfer the formula, right? Use a one parameters multiply the action. And if the parameters is gamma equal to 1, they will come back to the allowable stress design. But here, sometimes in this second design method, we always choose the gamma to 2 or 3. Use the simple parameters in the formula. Yeah, for this method, can you understand? Yeah, so with the method developed. And then nowadays, people think we use this parameters, this parameter equal to 2 or equal to 3 may cause the material waste, this problem. Yes, here is a 15, right? And actually the 20. If at here we use the parameters gamma to 3, so it will be 30, right? 30. So the R will need larger than 30. So the resistance in the structure design, we may design the resistance equal to 40 or 50, right? But actually, it's only the 10, right? So 10 to 50, there's some material waste in the design. So people realize this method may be too competitive. Can you know the meaning? 保守的，太保守了。In Chinese. Yeah, can you explain that 保守? Yes. Do you know the meaning of 保守? 保守 means we will do not 激进的。You don't know, right? 保守 is competitive. Can you know? Competitive 保守的。保守的。Yeah. I don't know how to say that, but for here, according to my describe, you will realize the setback, right? Setback of the second method. They will cause the waste in the design. So people or scientists, they think another method, the limit speed design method. This method based on probability design method. Yeah. Okay, I will continue. And for the third design method, we will introduce the later. Okay, wait a moment. Also, I will search it. Conserved.
Conservative.
Yeah, conservative. Yeah, this method. Yeah. So you understand because for here this parameters, this coefficient, we just see it's equal to 2 or equal to 3. They have not some experiment to support that. So it's the 10, right? We multiply 3, the coefficient, it should be 30. So when we do the design, we need to increase the resistance. Maybe it's reach to the 50, right? It reached to the 50. But actually the load only the 10. So there is a 40 values in here. It waste. So for second method, if you build a material, you will pay lots of resources in the structure construction. So conservative, right? Yes, conservative, the second method. But for the first method, it will be dangerous because we only to the parameters be 1 point, right? The parameters. So if there has a deviations, the resistance can't satisfy with the load, with the action. So the structure will be dangerous, will be failure. So it cost economy waste, like these things. So these two methods, we found the disadvantage, the factors. So people proposed. Nowadays, we also use the limit state design method. Limited state design method, they talk probability, or for load, they do statistic analysis. Statistic analysis, they based lots of data. Yeah, they based on lots of experiment. These things support this method. So this method is a major be used in structured design here. Yeah, because let's see something about, because for action, for the load, actually they had a discrete. What's the meaning of the discrete? Because when we use a mode, this is a mode, right? Mode. Okay, I will draw it. And for the concrete in here, the concrete in the mode, they had a hydration process, right? Hydration process, that means, look at here. Sometimes they had bubbles, right? Bubbles, some small cracks. Yeah, small cracks developed in the concrete during his hydration process. That means we even use the same mode and even use the concrete grid in reality. The value, maybe the mass we calculate from the concrete here, the value is different. This we make this practice, right? Because the mass m equal to the density, right? Multiply the value. Yeah. The density may be the same, right? But for the value, actually, we should these two samples should be solid. If it's solid, right? Solid, that means the values in the same mode, they can be the same. But actually, right, during his hydration of different humidity or different temperature, the bubbles occurs in this sample. Maybe there's a 2 bubbles, but here there's a 3, right? There's a 4. So we use these values to here. Actually, what we measured for the mass, maybe it's the 10.1, 10.3, 10.3, right? So this value has a discrete, right? Yeah, the same things we'll like to do to evaluate the resistance and the load, the action, right? So people's they bring this character value after he do the statistic analysis. Use the probability this concept in structure design. Here they consider this critique or deviation or this accidentally some factors. Yeah, the things, the design will be the design method, the design process will be accepted by lots of countries nowadays. Okay. Continue. Yeah. So in the chapter 2, the section of the load and the material properties, we will first to see talk about the knowledge of a statistic to talk about this knowledge, and then we will see the magic to learn the material property of the concrete and the steel. That's the reason why before I ask students that who drew the figure like that, because we also will learn. For steel, this is elastic, and there is a plastic, right? There and enhanced. This is the stress strain curve about the steel material, right? And we also will know, but for concrete, the curve is totally different with steel. Okay, and we also will see. Here, the permanent action, they fulfill the normal distribution here, and for the variable action, they fulfill the Gombe distribution. Here, I do the explain, right? For permanent load, like we just show here, for we calculate M. Right, we know the permanent load M multiplied G, right? G is always equal to 10, right?
And when it is 10.
Yeah, to 10. And then we get the gravity. So M, they have this discrete. So that means the gravity, permanent load, they had discrete. Oh, okay, take a rest.